Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to be going over how the complex ion equilibria can affect the solubility of your compound. So if we remember from a previous video, I had talked about how lowering the pH or increasing the acidity of a substance or a solution can actually increase the solubility of an ionic base, right? So if you have a basic ionic compound, then lowering the pH can get it to dissolve more because remember the H plus ions or the hydronium ions are reacting with the hydroxide ions, and therefore it's driving the dissolution towards more producing more of the hydroxide ion in solution according to Le Chatelier's principle. So in the same way, the solubility of an ionic compound that contains a metal cation that forms complex ions will also increase in the presence of a Lewis base. So let me underline that. In the presence of Lewis bases, that will also complex with that cation. And so we saw this before, where and I'll get to it in a minute, where if you have a stronger base that will replace the ions or replace the ligands in your complex ion. And so the most common Lewis bases that are going to increase the solubility of your metal cations are going to be your ammonia, your cyanide ion, and your hydroxide ion. So these are the three that are going to increase the solubility. So if we look at silver chloride, we know that silver chloride is not a very soluble salt. So if you looked at the solubility rules, you know that silver chloride is insoluble in water. It's going to dissolve a tiny, itsy bitsy, tiny bit, but not very much at all. So here is the equilibrium of your salt of silver chloride, and it's dissociated into your silver ions and your chloride ions. And you'll notice here the KSP, the solubility product constant, is 1.77 times 10 to the negative 10. And this is a really small solubility or solubility product constant. And so that indicates that this is not going to be very soluble in water. But we also saw in an earlier video that adding ammonia will increase the solubility of your silver ions. So your ammonia will complex with the silver ion. We saw earlier that silver plus doesn't exist. It's a complex ion with water, and the ammonia, which is a stronger Lewis base, is going to kick off the water molecules and bind to your silver ions, and so that's going to drive the solubility of your silver chloride. So again, according to Le Chatelier's principle, you're going to bind this into a complex with ammonia, creating the complex ion, therefore reducing the amount of silver ion here. So this is going to go down, which means that the silver chloride is going to have to dissolve more to make up for the lost silver ion. So according to Le Chatelier's principle, it's going to be driven towards the right, and so more of your salt will dissolve. So this is an example, and you can see here that the Kf for this process is very, very, very high. So this is going to form very readily. And so what we can do is we can then add these together to get the overall equation, right? So here you produce the silver ion here, and you use up the silver ion here. So we can cross that out. And so everything else stays. And so what you end up getting with your final equation is going to be your AgCl solid plus 2NH3 aqueous, and that's going to be in equilibrium with your Cl minus aqueous plus your complex ion of silver and ammonia. And so there's your final equation. So what it ends up being is you're reacting, you got your silver chloride solid, you throw in some ammonia, and the ammonia is going to complex with the silver to form your silver ion complex here, leaving the chloride ion there. And so to figure out what the new K value is, what the equilibrium constant of this, we learned from before that when you are adding equations up to get a resulting or final summary equation or a conclusion equation here, if these two add up to this one, then to get the equilibrium constant for this new equation, all you do is multiply these together. And when you multiply these together, you get an equilibrium constant that is equal to, let me look here for a second, it's going to be 3.0 times 10 to the negative 3. And so what you can see here is that the new equilibrium constant here is much greater than the equilibrium constant here. And so thereby, using the complex ion, you're increasing the solubility of this. So this is much more readily going to dissolve in this reaction here than just in pure water by itself. Okay, and so here, this is a pretty much like a 17 million fold difference between this and this. So I hope this was helpful. If this helped to clarify things about the effect of the complex ion equilibrium on solubility, please make sure you hit that like button and subscribe to my channel. Hit that notification bell right up there so you can be notified by any and all videos that I put up. And put a comment down in the comment section below. Let me know what you think, and if you've got any questions, I would love to hear from you. Thanks for joining me, and have a great day.